did our project because it kind of fits the first chapter, but really it leads more into what we're going to do for the next chapter. And actually, when I say the next chapter, I kind of take things out of order as far as the book's concerned, just because I feel like, funny enough, chapter 5 material fits better after this section. So we're actually going to cover like a couple sections from chapter 5 after we finish chapter 1. And we'll come back to chapter 2 and kind of go from there. But anyhow, this last section kind of fits more like with the chapter 5 stuff than it does the chapter 1. But it still has some that ties into what we have been doing. So that's kind of why I waited to cover it. But I'm going to do the first part today. We'll cover the second part on Tuesday next week, or no, you guys will have Monday next week. And then at the end of next week on Friday, I'm planning on having our chapter 1 test. So kind of looking ahead on that one. But here's what we got for section 1.9 to start. We got 25 different students in Mr. Pryor's stats class. And here are all the scores that they had on their first test. The 86 is bolded because that's Jenny's score. Well, if we ask, well, how did she perform on the test relative to her classmates? In other words, okay, she got test scores back. Mr. Pryor showed them all those scores, and she went home to tell her mom that, okay, I got an 86. Here's how I compared to everybody else in the class. What might be some of the things she tells her mom? What are some things that she may mention that we've talked about already? What might be some terms that she would use in terms of data itself? What might be some important information that you'd pick out? If I gave you these numbers and I said, okay, do some analyzing with the numbers, what might be some things you'd find out?
I don't know, this is boring, but she's the only one that got an 86.
Okay, so I was the only one that got an 86. All right, so that distinguishes herself.
It's the third highest score.
Okay, so I might say, all right, what's the third highest score? All right, which may be important. You know, what might be some other things? What are some computations we've been doing lately? What might she compare her score to? Pardon?
She could compare her score to the highest score and the lowest score.
Okay, so we talked about range for the highest and lowest scores, so she can compare it to those two scores. All right, maybe did you have an idea?
I just said like she could do like compare her grade to like single one.
Okay, so compare it to the lowest 25%, see how she compared to that. All right. Your teachers, whenever they hand back the test, say, okay, here was what the class length was. Average, class average was. All right, so maybe she compares it to the mean. All right, well, the average was such and such. I got a this, which hopefully was better than the average. All right, so we've had a lot of different things that we've talked about that she might mention. However, if I go back to what Macy said, she got the third highest score. Well, that could be really important, or maybe it's not very significant. In other words, say that most of the class was gone that day I gave the test, and only 6 people took the test. Well, having the third highest score, kind of not that big a deal then, right? But maybe I took all 2 sections of my stats class, and I listed all those scores out, and so I had 60 people, and I got the third highest score. Well, that's more significant. So sometimes what we want to do is we want to do a comparison in relative terms. And we've used that word relative before when we did a relative frequency chart. So what we're going to do is we're going to find ways that we can say, okay, not only did I get an 86, which is the third highest score, but this is how it was as far as how it fits into all the data itself. Well, one of the ways that we're going to make that description is we're going to use what's called a percentile. What's a percentile? Well, a percentile, just like it sounds, is a percent. So it's a percent of the values in a distribution that are below, actually, I guess a better way of saying it is that are lower or less than the individual's data value. And you've probably heard that term before, percentile, like whenever you did any testing like SAT, ACT, they say you scored at the 50th percentile, the 80th percentile. When you were younger and you used to go to the doctor, they probably told your parents, well, their height is at the 75th percentile, or their weight is at the 90th percentile. So you might have heard that term before, but what it means is if I have a certain value for the percentile, that means that percent of the values are less than that. So if I said I'm at the 80th percentile, that means 80% of the values are less than what I'm at. So when we look at a percentile, that allows us to compare it to the rest of the values in the distribution. So let's go back to Jenny's score here, and let's see if we can figure out what her percentile is. So probably hard to see on your sheet, but here is Jenny's score, that 86 that she had. Well, if I'm going to find the percentile, what I want to know is what percent of the scores were less than Jenny's score. Well, in this case, we've got a lot of them that were less than her score. So it might be faster to figure out how many scores were, including hers, and above. So if I look at the scores that she had and the ones that were above, that's 4 of the scores that we were looking at. Well, how many students did we have in the class again? 25. So if 4 of them were at her score or above, the other 21 were below. So to find the percentile, we're going to look at, well, what is 21 out of 25? We're going to find that percentage. Well, 21 out of 25 would be, first of all, when I divided it, it would be 0.84. Or in other words, she's at the 84th percentile, which means 84% of the scores were below hers. So in relative terms, she did pretty well if 84% of the scores were less than what she got. It's not a huge thing, but just kind of semantics here. Make sure that an accurate description is to say that Jenny is at that 84th percentile. Sometimes you'll hear people say that I'm in the 84th percentile, which technically the percentile is an actual value. So you're going to be exactly at a certain percentile. It's not a big deal, but just something if you're going to really be accurate, you want to say at the 84th. All right, so let's look at a couple type examples that we might use percentiles right now. So I've got this dot plot. This is from the 2014 baseball season. And we want to try to figure out, well, what percentile that the St. Louis Cardinals were at that year when they won 90 games. So the first thing I want to do is I want to figure out how many scores or how many teams had less than 90 wins that year. So I'm going to go to the 90 win mark here. And again, it looks like a majority of them were below that. So I might just count the ones that were at 90 and above to begin with. So if I look at this, I had 1, 2, 3, 4, 5, 6 that were at 90 or above. They said there were 30 major league teams. So if 6 were at 90 or above, that means 24 were below that. So I want to see what that percentage is if I did 24 out of 30.
8%.
How much?
8%.
Did you get 0.8?
Yeah.
Okay, so we got 0.8. We'll have to move 2 decimal places. So we're looking at, 80th percentile. So we'd say they were at the 80th percentile for wins that year. Or in other words, 80% of the other teams had less wins. So that's one thing we're going to have to be able to do. Given a certain value, figure out what its percentile is. Sometimes we have to go in reverse though. So this next example talks about the Cubs that year. And it says the Chicago Cubs, their number of wins were at the 20th percentile. We want to do a couple things. We want to do what's called interpreting this value in context. And secondly, we want to know, well, how many games did they actually win that year? All right, so let's start with the interpretation. Well, if they're at the 20th percentile, what that means is 20% of the scores were what? Above them or below them? Below, yeah. So the interpretation would be 20% of the other teams had less wins. Any Cub fans in here? I was kind of picking on you here that last time. The Cardinals were that much better than the Cubs. But that's what it means. That's what 20th percentile means. The second question, though, wants to know, well, how many games did they actually win then? If they were at the 20th percentile, how many games did they actually win? Well, in order to answer that, we need to know, well, what is 20% of the teams? So if they're at the 20th percentile, I'm going to try to figure out, well, what is 20% of the total? In this case, we had 30 teams. So if I take 20% of 30, that's going to be 6, which means only 6 teams had less wins than what they did. So I'm going to go back to my dot plot, and I'm going to start counting from the left side. Those were the 6 lowest win totals. So I'm going to go through and I'm going to count these. So I've got 1, 2, 3, 4, 5, 6. So those 6 would have been less than that. So I go to the next marker here and I try to figure out what that win total was. Well, it looks like it's just past halfway in between these two. So it looks like they had 73 wins that year. So because there were 6 below them, they had 73 wins. So going back to what we did there, it was 20% of the total. So we figured out how many that was. And once we knew how many that was, we just counted those values and then went to the next value that we're looking at. So that's a little bit trickier than just finding the percentile. But for right now, we'll work on finding the percentile, or given the percentile, try to find the amount. Those two things. All right, last thing we're going to do today is look at a way that we can graph using percentiles. And really, the one way that we're going to do that is we're going to use what's called a cumulative relative frequency graph. It sounds pretty fancy, but cumulative just means we have a running total. We're going to accumulate things. Relative, we've already used that term before. What's that usually mean we're talking about when we did a relative frequency table? Percentage, right. So basically we're making a running total on the percentages is what we're going to do when we make this table or when we make the graph. But in order to make the graph, we first of all have to make a table. All right, so we're going back to these test scores here. And what we're going to begin with is figure out, and I already gave you a table to start, but we're going to figure out, okay, how many scores fit in the 67 to 71 range, I may fit in the 72 to 76, and so on. Now notice it's not like the histograms where you have to worry about the ones on the edge. It has 71 and then it's 72, so there isn't any that double up like we have for histograms, so you don't have to worry about that. All right, but go ahead and go through it and see how many you have in each of those based on the data. Tallies are a good way to keep track here, but make sure you write your total down once you have all your tallies in. Once you're done finding the frequency or how many times those show up, the next column you're going to label with percentage or percent. And then you're going to find out what percent we have for each of those intervals. Now remember, we had 25 students in that class. So whenever you find your percentage, you're going to take the value and divide it by 25 to get your decimal, and then convert that to a percentage. So go ahead and see if you can find your percentages for each of the intervals. So far, it's really nothing different than what we've done before. We've done frequency tables, done relative frequency tables. The one extra step is the cumulative part. So the cumulative part, again, just means I'm going to keep a running total. Well, at the beginning here, I didn't have anything before I got to that first value that gave me 4%. So my running total is just at 4% right now. So I didn't have anything before that. But then I'm going to add another 20% to it. So now I'm up to 24%. So if you kind of visualize what's happening so far, if I were going back to that dot plot, when I got to 76, so that was here, when I got to 76, that means right now I would have been looking at 24% of the scores. So that running total from left to right had given me 24% of the score. Now I'm going to keep moving on to the next one. And so I'm going to add another 36% to that 24. So now we're up to 60%. So again, if I were to look at the dot plot, by the time I got to 81, I would have had 60% of my scores already. Then we'll add 28 to it. Go up to 88. Add 8 more to it, 96. And finally add 4 to it. And I got what I want, which would be 100% back. If I've done it right, I should always end at 100%. All right, so that's kind of the tedious work, figuring out those percentages.
So the 100% will always be at the end?
Should be. The only reason it wouldn't is if somehow we had to do some rounding here, and it may be slightly off of that, but it should always end up at 100%. That would tell me I've used every value now.
So you just have to add them all and then get a, wait, no, you don't have to add them.
Well, and you could have double checked yourself here and added them, make sure you got 100, but I'm just making a running total as I go. So I'm adding as I went.
Okay.
Okay. All right, well, here's what we're going to do on our graph. We're going to make a graph that has this on the x-axis, and it has this on the y-axis. So our lowest value here was 67. Our highest value was 96. The nice thing is the interval's already been set up for us. We went by 4s. So when we set up our graph, again, we're going to have an x and y axis label. On the x-axis, it's okay if I start at that first value, that value of 67. And then, like I said, our intervals basically went by 4s. When we label it, though, what we're going to label it with are the first values. So even though our intervals were by 4s, we're going to label the first values. So really, we're going to go by 5s on our markers. And that'll make more sense if we start graphing it. So I started at 67. The next one I'm going to mark is going to be 72. So I'm going to go by 5s, really. Remember, these are our scores. And the y-axis will be our percentages. I'm going to go by 5s. I'm only going to label it for every 10, but I'm going to go by 5s. And then we're gonna go up to 100. All right, making the points on this, and I've been doing these for quite a while, and I always have to think through it still, because it's kind of strange. I think it's kind of strange the way you started out. But if you think about when I started at 67, my running total was actually at 0 at that point. So I'm going to start out with 67, this lowest value. I'm actually going to start it at 0. And then by the time I got to 72, so in other words, by the time I got from 67 to 72, I was up to 4%. So even though 4% is talking about this interval, we're going to actually mark it at 72. So at 72, I'm going to mark it at 4%, just below that mark there. Then by the time I got to 77, so by the time I got here, I now was at 24%. So 77, I'm going to mark at 24%. Our next total after that was 60. So I'm going to mark that at 82. Seven was all the way up to 80. And then 2 will mark at 96. And by the time we get to 97, we've now talked about all the values. And then you're going to connect those together, just one segment at a time. So that would be our relative cumulative, or cumulative relative frequency chart. Okay. Here's good news. That's the last one you're going to have to make. Okay. I think it's more important that you can read it and pick out information from one versus being able to make one. But I did want you to see where the graphs come from, where you get those values from. So you won't have to make one necessarily, but you will have to go pick out information from a graph like this. For instance, let's say I looked at this graph and I said, okay, well, I got a 90 on my test. What percentile did I score at? Well, what I could do is I could go to this graph and I could find out approximately where 90 is. So I'm looking at 90 in here. I can go up to my graph and I can see what the running total was at that point. Well, it looks like my running total at that point was 95% roughly. So that would tell me I was at the 95th percentile because 95% of my scores were less than what mine was. Or we could think in reverse. If I said, okay, I'm going to make a curve where if you were at the 70th percentile, you're going to get an A. So anybody at 70th percentile or higher will get an A. Well, I could use my table or my graph here by going to 70%, and then I could see, okay, well, what score would that be? Well, if I did that, it would be roughly in between those two, so I'm looking at about an 84%. Okay, so being able to read it, to me, is more important than being able to make one on there. So let's do one example where we have to read it, and then that'll be it for this part today. So here we've got this cumulative relative frequency graph. It's talking about the median household incomes in the 50 states. So notice again, they have the values here, they get the cumulative percentages here. Well, the first question related to this graph wants to know at what percentile is North Dakota if North Dakota had the median household income of $55,766. So to answer this question, we're going to go to where that value is on the x-axis. So I'm going to go over here to where that 55,000 roughly is. And I'm going to go straight up to the graph. So it looks like it's at that point there. So what I'm going to do then is decide, well, where is that point as far as my running total? Straight. So what are we looking at approximately as far as our percentage here? What might you say? Okay, 63 up by that. So we're looking at the 63rd percentile. If you said 62, 61, that would have been okay. Anything around there would have been okay. So that would be where we knew the value, we want to find the percentile. The second one is going in reverse because they want to know about the first quartile. Well, before we can figure out what first quartile is, we got to think about, well, what percentile is that? When we do the first quartile, how many scores are below that value? What percentage of scores? 25. So when I talk about the first quartile, we're really talking about a 25th percentile. Because 25% of the values are less than that. So now, again, we're going in reverse. So I'm going to start at the 25th percentile. I'm going to go to the graph. And then I'm going to approximate what that value is. So it looks like in this case, we're looking at something at about $45,000. That would be the estimate. The interpretation. Well, the interpretation would be putting these two things together. The fact that it's at the 25th percentile and this is the value. So what I would say is 25% of the states have a median income less than $45,000. That would be the interpretation. Saying why there was, or what percentage were less, and they were less than a certain amount. So like I said, for right now, percentile wise, you should know what a percentile is and how to find it, or be able to go backwards as far as I give you the percentile, find the value. Or the same thing from the graph. If I give you a value, you have to find the percentile, or if I give you the percentile, you got to be able to find the value. We'll add to that next week. On Monday, we'll add to the second part for 1.9. And then I'll give you problems related to both those things after that. And then, like I said, on Friday next week, we'll have our chapter 1 test. So Wednesday, we'll spend kind of reviewing, getting ready for that. So no problems right now as far as this is concerned. So the time we have left, we got about 20 minutes left. We can kind of wrap up hopefully your projects.